am the chair of IEEE SCC 21, which is responsible for starting new standards and information material on distributed energy systems, as well as interoperability and smart grid. I'll talk a little bit about how that gets done within IEEE. My objective today was to give you kind of a high-level snapshot of what's happening. And if there's further interest, we'll have to do a deeper dive into some of the technical detail. I had been working with Dan Ebert on some proposals related to the MWork organization, but he wanted to get this working group's opinion if there is a legitimate opportunity for MWork to be a participant in these standards. Okay. Okay, so a little bit of background on how the IEEE works. There's 22 societies. I've listed some of the ones my committee works with the most: Computer Society, the Power and Energy Society, the Industrial Applications Society, Communication Society, as well as Power Electronics. Those are kind of the core groups where I was trying to do outreach. As I mentioned, I'm the chair of this coordinating committee, which, and I'll explain how that fits into this. And I've also been talking to Dan and introducing him to the IEEE Industry Standards Technology Organization, which is affiliated with IEEE, but has a different model to facilitate organizations like MWork being able to develop standards very quickly, much faster than the typical timeline. So this SCC 21 is a committee that was appointed back in 1981. We coordinate efforts in these fields of fuel cells, photovoltaics, dispersed generation, and energy storage. So I've been a leader in this group for 4 years. I've been trying to change the scope and the name, and it's just like pulling teeth to get that updated. But it was done 31 years ago. So you can see the datedness of that title. And really, we focus on standards that are broader than the scope of any one of those societies I just mentioned. And we are, as we look forward, we're seeing a lot more communications interoperability rather than the hardware standards. So we're adapting what we're doing to that. We've been in place since 1981, and the committee reports directly to the standards board. And really it is for projects that are too broad for one society. For example, I'm going to be talking about IEEE 1547. That has a lot of material from Power and Energy Society, Power Electronics Society, Communications, and Computer Society. So we pulled everybody together to get that accomplished. And there are some we picked up where the society that started a project within our scope hasn't been able to move it forward. There's a lot of new initiatives related to distributed energy, but that can be discussion for another time. So this is a graphic that shows the areas where SCC 21 is responsible. We have 3 general series, interconnection series, the 1547. Many of you may have heard of that. The Smart Grid Interoperability series, which deals with the integration of power, communications, and IT, and solar PV, which are really some energy storage standards for off-grid installations. The typical process we go through on these broad-based standards would be to have a base standard approved, and the one we're going to be talking about was approved in mid-2018. Another standard, which is the test procedures, was approved earlier this month, or actually March 5th, early last month. And then that's being coordinated with UL 1741. They're going to have a special version of that that'll be released in around May. And then finally, over time, many of these things will be in the 2020 National Electrical Code. And these are all coordinated with IEC and FPA. And in the particular, the standards we're talking about, NERC was very involved in that as well. So I'm not going to read this. This is a listing of the standards we have related to interconnection. The blue ones are active working groups, such as an application guide, guide for cybersecurity that was just kicked off last month, and guide for energy storage interconnection. This 2030.5 is a smart energy profile that's being used within California Rule 21. And we're just starting a revision of the base interoperability standard. My point of showing you this is if you're interested, if you're a member of IEEE, you can sign up as an interested party in these working groups. Here's a partial list of the 2030 standards, but the ones that are, I think, are active and most interesting for you are the ones that are in blue. Such as, and the ones that are not in blue that may be of interest for reference is 2030.7, which is a standard for microgrid controllers that really deals with the nomenclature used in the control system. And this also relates to that, the testing of microgrid controllers. Okay. So I'm going to switch gears now. I just gave you a little bit of background on how things typically work. The one thing I didn't say is that cycle to start a standard to the time it's published is typically 4 years. In some cases, it'll be extended by the standards board, but it's a long, complicated process. And the thing I didn't say, the typical process that IEEE follows is very open, so everybody has to have the opportunity to participate and to vote on these standards. Today, I'm going to hopefully convince you that there are significant changes coming to both the standards and the codes and regulations as a result of the 1547 approval in 2018. The reason that was made, the revision was made, and it was such a pervasive, wide-ranging change is that in some markets, the high penetration of inverter or renewable sources were driving some performance issues on the grid. There was not a common language or a set of requirements for inverters and or synchronous generators. And there was always need for guidance on how to apply them. The earlier standards published in the 2000s were somewhat short and sweet, but that vagueness leads to confusion in the industry. And one of the more recent changes that you're going to start seeing a lot is interoperability requirements, specifying specific communication information that is required to be available in any distributed energy resource. Okay. I'm going to talk a little bit about 1547 and the accompanying 1547.1. Just a sidebar, the test procedures were approved on March 5th, and NARUC, National Association of Regulators and Utility Commissioners, and the affiliated state body of state electric regulators are working through those requirements to determine interconnection rules in each state's territory. Some of them are further along than others, and I'm not going to get into that today. But highlighting the requirements are DER is required to be able to regulate voltage and frequency within ranges at the point of connection. For abnormal conditions, DER are required to be able to ride through disturbances instead of the old rule of disconnecting within 2 seconds and reconnecting in 5 minutes. There's a much more complicated set of requirements. For intentional islands, and that's where the discussion on microgrids are, you have some unique requirements if the microgrid includes part of the distribution network of the utility. And there are also fairly extensive discussion on the technical requirements for microgrids, and just the fact that that exists now, we would expect the industry to really take off in that area now that it's discussed and endorsed. And then all DER are expected to be capable of meeting the interoperability requirements, and that's information like nameplate and configuration, plus monitoring information on what's happening, the power output, state of charge, and as well as the settings that are required for that region. And it does specify certain protocols will be used. So all DER after a certain point will be required to have this information. And the last area of change is the verification process. There's some new steps related to verifying that the design meets the local requirements, as well as the new rules allow system type testing. So for example, instead of the previous rules just talked about an inverter box meeting technical requirements, you're now able to test an entire system, and that could be a master controller, several inverters, energy storage devices, and solar PV, as long as the manufacturer sees it as an economically viable investment. They can type test that whole system, which will streamline the integration and commissioning process. So I'm going to divert and go into a little more detail on a couple of these. I just got one slide or two slides for each of them just to show you what we mean and why these changes are significant. This chart shows the original standard, which is still in force in many places in the US. It was passed in 2003. The technical requirements really focused on distribution system, anti-islanding requirements, and was really meant as an interconnection standard, but ended up being used for equipment listing for inverters. But it only specifies the electrical requirements for the interconnection system. The new standard I'm talking about today has the power interface requirements, but also has a communication interface requirements. And the changes are that it's focused on the distribution network and bulk system requirements. Bulk power meaning bulk generation, large power plants. The specification encompasses the whole DER, and type testing can be used for an equipment listing as well as a plant level verification, which is another word for a system type test. And there are interoperability communication requirements. Another way to look at the change in that area for performance under normal conditions, if you look at the original standard, many of you are familiar with it, it basically says you shall not actively regulate voltage at the point of connection, and you shall trip on abnormal voltage or frequency and reconnect on your own in 5 minutes. The new standard, or the revision, says all DERs shall be capable of actively regulating voltage. It's a little different from the previous one. You shall ride through abnormal voltage and frequency conditions, and you shall be capable of frequency response if desired by the electric power system operator. Another background piece on why this ride-through was developed. Here's a case study on the next two slides of an event that happened in 2017. It was a 1,200 megawatt solar resource loss. It was 26 large-scale solar power developments, and the voltage loss was incorrect, but one of the inverter systems sensed a low frequency and tripped. And as you can see, 1,200 megawatts tripped instantaneously because of that incorrect inverter sensing of a frequency. So instantaneously lost 1,700 megawatts. That's the whole system impact. And you could see it took the time scale is 10 minutes. It took, nearly 10 minutes to recover that capacity. And the scale is megawatts of solar PV available on the Southern Cal Edison system. So what happened is, under the old rules I just showed you, the faulty frequency event due to a fire caused that inverter to cease to energize and return to service after 5 minutes, which is what the rules said you had to do, although it was an incorrect sensing. What happened as a result of that is, this is a graph of the Western interconnection, which is the western half of the US, basically showed a change from nominal 60 hertz down to 59 hertz, which is a reportable event, and you can see it took 5 minutes to recover. So that system failure affected the entire Western interconnection. All those manufacturers that were involved were in meetings for 1.5 years trying to explain what happened. The implications of this is that we revised the requirements for inverters and the response to abnormal conditions to include ride-through requirements for voltage and frequency, with a lot of adjustability to allow for different regions to accommodate different, different needs based on their circuit and penetration of DER. How's the pace, everybody? Doing okay?
Yeah, we're doing okay, Mark.
Okay. I'm famous for losing my audience, and I can't see you, so I just want to make sure. All right, so I'm going to shift gears. How does this all wrap up? This is a chart I recently put together that's sort of a timeline, and the left two boxes are, from 2003 to 2016, 2017, those existing rules that told these systems to disconnect under whatever happens that's out of tolerance existed. And when California Rule 21 started up in 2016, and it's a phased implementation, all of those requirements are included in this IEEE 1547, which includes these details I just went through. The test procedure was just approved, and the UL 1741 Supplement B is going to be issued mid-year. So we have all the technical requirements and test procedures, and the manufacturers are working towards having certified products available probably by the end of 2022, but most of them will be available in 2021 is our current thinking. But we are expecting enforcement anticipated by the states. So I mentioned this briefly in February last month. NARUC had a formal resolution, meaning this is approved, where it recommends state commissions adopt IEEE 1547 and align the implementation of standards with the availability of certified equipment. Okay, so we're expecting that to happen as early as next year, but certainly by 2022. There's other standards going on that are dealing with certain aspects of it. IEEE 2800 is adopting the 1547 requirements, but there's some unique things for inverter-based systems that are connected to the transmission system. And those are mainly large-scale solar and wind systems. 2030.11 is an interoperability guide for distributed energy resource management systems. And those are systems that could include aggregation systems from a third party or from a transmission operator or utility wanting to manage multiple distributed energy resources. We're actually waiting for approval from the standards board 2 weeks from now for the revision of the base 2030 smart grid standard. And if that gets approved, we'll start organizing meetings in May. As we work through with the questions from equipment manufacturers and utilities, I would anticipate that microgrids are going to require comprehensive commissioning in combination with a project, and there's technical reasons for that. But I think that's an area that MWORK could really help the industry with your experience and commercial focus in this space. Two other areas that maybe become more important are system modeling as opposed to physical testing in the field, and type testing of systems. I'll explain that in a minute. So, you know, one of the potential gaps, the two of them are interoperability. How do we verify that that system meets the requirements? And a new area that's being embedded in many of the newer standards is cybersecurity, which was excluded from the original standard. And microgrid and DERMS execution integration. What I mean by that is that the 1547, it prescribes some specific steps. In this chart here on the right, it's read from bottom to top. Conformance testing is like it has been, type tests and production tests. But the type tests can be done on a system. We don't know who's going to do that. The industry isn't required to do it now, but in the next 2 years, the organizations that want to perform that will emerge. There's two new steps in the verification process, a design evaluation to make sure the system meets what was required. You know, just a sidebar story on that. In North Carolina, 2 years ago, there was a survey of 51 megawatt solar PV systems, and 40% of them had the wrong inverter settings, even though it was in the contract. And another 30% of those had the wrong grounding configuration. So there needs to be checks on the systems that are being installed. Are they actually what's required by the contractor, by the region? And another step is an as-built installation evaluation. I'm pointing this out because, you know, those industries and those practices don't exist today, and that may be another area that MWORK could assist the industry or provide guidance through its members. Another area that will continue to be a lot of debate is how to integrate energy storage systems. And, you know, there's debates around, is an energy storage system the same as a solar PV or a synchronous generator system in terms of interoperability? I mean, we need to determine that, and with MWORK's knowledge base, could be an important player in developing this industry. There's some niche segments we're evaluating, and there may be new standards projects started later this year. One of them is on grid forming inverters. Most of the inverters studied and discussed are grid connected, meaning they need a reference waveform to function. Grid forming inverters have a lot of applications and could, if the industry is commercially ready, we may develop some separate standards for those. There may be an application guide for off-grid systems. The example situation would be a lot of people in Alaska are interested in 1547, which gives very specific requirements, but most of the utility systems in Alaska are not connected to a central transmission system. Only the ones on the rail belt from Fairbanks down to the coast are connected, and the rest of them are isolated systems. So there may be an application for the interconnection standard for those systems that are typically 3 diesel generators trying to integrate some solar PV and wind. There's going to be a lot of more work done on transmission connected inverter systems and on modular microgrid solutions. One plausible solution is we begin to see packaged systems that can be implemented very quickly, which could include emergency generators, energy storage with UPS functionality, and the ability to integrate renewable sources when available. And there is some interest in doing that with our current situation with COVID-19 to come up with package systems that could convert a hotel into a hospital or critical care facility. The easier it is to implement, the fewer steps you have to integrate the system, the better off we all are. Last slide, potential next steps. Today I wanted to present to you an overview of the situation, and I look forward to hearing your comments on whether or not those areas make sense to you as members of MWork. But really the next step is working with Dan, and your feedback would be to identify a few target areas on that gap list I just identified and evaluate the business model for MWork. And that you can't just turn it on. There's some tax issues, there's some project management issues related to developing standards if you wish to have it ANSI certified, or if you wish to communicate to the industry. There's just some things that have to be evaluated because there's a cost benefit. But one implication could be, as we incorporate some of the integration issues, as I mentioned here, this process, or the interoperability issues, that could very likely generate many new members for MWork, because there's companies in this region that are big players in that space, but they're not currently involved with MWork. Another possibility would be to put on a workshop on this. That was one of the things that I've talked about several times in the past, but hasn't had any traction. An example of one that was done, it went through the IEEE Smart Grid website. Working with IEEE, they send out like 7,000 or 8,000 invitations for these webinars. They charge $150 a piece for a 4-hour session. And so they made a chunk of money out of posting these. And one of the hooks is you can issue professional development hours certificates for registered engineers by putting that on. You need some lead time, and you need to make sure who your target investment is. And this wouldn't be things like me speaking. I have 10 other speakers that were officers of these committees that would make these presentations, either members of utilities or national labs, or independent consultants. And then, another possibility would be interoperability. That's going to be a really hot issue, and some of that may be available via webinar with or without MWork, but it would be a way to associate MWork with smart grid, cybersecurity, and interoperability, which no organization's really stepped up to lead that. So those are the slides. I hope I communicated that there is big change coming. And I'd like to open it up for questions if we've got time.
Yeah, thank you, Mark. Yeah, we do have time. Timony and